Good morning
Good morning.
to you and you. All right, so everyone has all the notes for this chapter already, hopefully. Do you guys all find 5.2?
Yes,
Yeah. Okay, good. All right. Area is remarkably easy. Yes, I am sure. Yeah, positive. All right. Area under the graph of function. Find the area under the graph of function. This is, yeah. Anyway, we're gonna get to the calculator stuff on this here pretty soon. That's probably going to be the longest part of all this. Integral and the fundamental theory of calculus comprise big three, idea 3, AP calculus. Now, that's just the antiderivative. Antiderivative. The area under the curve is the antiderivative. Because we were using the antiderivative to go from acceleration to velocity to position. Now, yeah, it's just the antiderivative, so it's the area under the curve. And then we have the definite integral, which would be from one point to the other. So where do I start? When do I stop? That's it. So, okay, if I were to graph this, okay, let's say for instance, I don't like the fact that they put h in here, so I'm going to put a number. Let's say f of h is 4. Or, f of, there. F of x is 4. That's my straight line, right? Yeah? And it's between the points of A and B, but let's give that a 1 and a 3. But you could just look at this and tell me, from here to here, if this is f of 4, could you tell me the area of that? The area of the shaded? It's going to be 8, right? Because the height is going to be 4, right? The height is 4, and the width from A to B from 1 to 3 is just going to be 2, isn't it? So the area under the curve of this, even though it doesn't curve, it's just going to be 8. It's going to be 8 units squared. But now I'm going to show you how to write this one in mathematical sense. So if I'm going from 1 to 3, I would start with my lower bound of 1, my upper bound of 3, and my f of x, which is 4, and that would be dx, because it's for the x. It means the same thing. But now we're going to start dealing with things that are actually a curvy curve. So under the curve, right now it's just flat. But we're going to deal with curves. And so you really can't draw a straight line off of that to be able to get it. So we're be able to do it in different ways. This graph consists of 3 horizontal lines, each positive height as shown in the figure are area A enclosed by the graph of f and the x-axis. Good morning. I can't get a good morning?
It's not a good morning.
Can I at least get a morning?
Morning.
It is morning, right? Okay. At least that. At least morning. Okay. So it says a whole bunch of words, but a lot of people get screwed up by that. The area A, So the area, the whole area, is referred to as just A. Okay, enclosed by the graph of f, okay, this one right here, in this case, is a step function. Okay, so they're saying this. The x-axis, so it's enclosed. That means that, you know, my graph actually keeps going down to negative numbers, doesn't it? So yes.
Yeah.
Good. So when I'm doing this, it's enclosed by it. So that means that it stops there. So it's enclosed by that. Okay. And lines x equals A and x equals B. So in between A and B. So that means that I am closing off from here to here. So as you do this, if you are drawing this, that's going to help you out so much more. Draw in your shapes of what you need to actually enclose, because we're going to find the area of only that piece. Because a lot of times we won't start right on the axis, so we can't say that, you know, starting from 0 to here, my units, no, I start from here. Sometimes I'll even start in the negatives. And I'd have to count the distance over from there to there. So you have to enclose it and to know where you're going. Okay. Does that make sense? And so in this case right here, to find the total area, what would I do? What would I do to find the total area? Let's go piece by piece. A1, what would I do? Length times width, right? Okay, so I figure out whatever my function is here, right? That encloses the top, and then whatever my x1 right here would be, right? So whatever the distance for that, times the height, which in this case would be my f of x. Okay. Same thing for A2 and A3. And then what would I do to get the total? Yeah, there we go. Add them up. Okay, approximate the area under a graph of a function. Approximate the area A, region enclosed by the graph of 12x plus 3. So it's enclosed by the graph 12x plus 3. So that means right there. The x-axis, okay, so now I'm closing in my box of where I'm dealing with here. My x-axis is going to be right here, right? So the whole x-axis, so I'm closing all this. And the lines, x equals 2 and x equals 4. X equals 2 and x equals 4. There we go. All right, we're going to estimate this now. So let's estimate it though. If I were to estimate it, what values would I use to estimate it? I know for the width, what would I always use for the width though? 2. Yeah, that's good. So I would say my width is always going to be 2 here. But what about my height?
3.
Not 3. 4. Okay, I could do a 4, right? So if I'm going to close it right there, and it would be 2 by 4, right? Which is going to give me 8. Is that going to be an overestimate or an underestimate? Underestimate, right? Because there's still part of it that is not covered, right? That is not inside that rectangle. So an underestimate would be 8 units. What about an overestimate? What would I use for my height for an overestimate? I would use 5. Very good. I'd use 5 because I would start over here. So having 5, that would be an overestimate. Okay, so 2 times 5, so that's 10 units squared. You all right? Okay. So I have an overestimate and an underestimate. Now, the two ways we just did this without actually even labeling it, we did a left hand. So we're estimating a left hand, so that means always going to make my rectangles where the left side connects to my function. Okay? We did a left hand. In that case, it was an underestimate. What about a right hand? What a right hand? That was my overestimate, right? Okay, so that's super important to understand. So that would be an overestimate for all of these. Okay, and it says make W equal 1. So what that is saying is, I am going to do this. If W is 1, I'm going to change this right there. The width. So if the width is 1, so now what did I just do there? I made it smaller rectangles. Do you think that would be closer to the right answer? Okay, so now let's try it with the left hand. I would like you guys to try it yourself right now with the left hand. Try it with the left hand right now. All right, what do we get for a left hand? What about, no, got to do both of them though. So left hand for both of them. So we're doing this here and this here. What is it?
4 and 5, 9.
No.
No? You use 9? Use 5 times? Yeah, 9.
No.
What?
No.
4 plus 1 times 4 equals 4, and then you add 5 times.
Left hand.
From the left, or is the second one still the same? So would it be?
The second one, what is the left hand to the second one? 4.5.
4.5, almost.
Right? So that would be halfway in between, wouldn't it? So that would be 4.5 for the height. And so together on a left hand, that would be 8.5. And that, in this case, is an underestimate. All right, let's try it with the right hand then. Tar, what'd you get on that one?
On the right hand?
Yeah.
8.
No? Hmm? Total. I want total. Total. 9.5. There we go. because a left hand would look like this. Yeah? Okay, so by making the W smaller or cutting it into smaller rectangles, what do you think I did there?
Make it more accurate.
Yes. Because with just one, my underestimate was 8 and my overestimate was 10. But when I added another one, right? So I split it in two. I got 8.5 and then I got 9.5. So if I sliced up each one of those again, what are you thinking that will do?
Closer to the answer.
Yeah, it would be closer to the actual answer. Now, do you want me to show you the cheater method or do you want me to show you the calculus?
Cheater method. Never with the calculus.
Never with the calculus?
Always the cheater.
Okay.
Both.
What shape is that?
That's a
That's a
trapezoid.
rectangle.
It's a trapezoid, right?
The trapezoid thing. And
Yeah. So area is equal to 1/2. H in this case is 2. And my base 1 is 2. My base 2 is 4. So that's going to be
same.
2 and 4?
oh, it's not 2 and 4, is it?
4 and 5.
Yes, it's 4 and 5. There we go. Sorry. Yeah, I did the wrong one. 4 and 5. Thank you for that one. Yeah, here, you're in that one. All right, so my area is actually 9 units squared. Basic math works all the time, even with calculus. A lot of time, everyone overthinks it so much that you can be like, it's just a rectangle. Just do the rectangle. That's it. Yeah. I think last year we had a problem with the BC. They were struggling so hard with one of the problems. I'm like, it's just a circle. That's it. It's the area of a circle. Anyway. But yeah, we were digging in something deeper. All right. Here's x squared from 1 to 10. 2 subintervals, 5 subintervals, 10 subintervals. Now, doing that many, it's kind of pointless. It's defeating. Now, this says by using lower sums. Lower sums, in this case right here, it is rectangles that lie under the graph. And if my graph goes from 0 to 10, and I want 2 subintervals, to figure out my intervals, it's going to be like this. It's going to be my b minus a divided by n. That's going to give me my subintervals. That's how wide each rectangle is supposed to be. Okay, that's always for my subintervals. So in this case, it would be 10 minus 0 divided by 2, which is 5. So I go over here, 1, 2, 3, 4, 5. Bam, right there. And so lower, in that case, that would be a left side, wouldn't it? Would that be a left hand there?
Yeah.
So yeah. So lower would be a left hand. So the left hand, what's the lowest part of the left hand? The height of it is 0, right? So this goes all the way, so this has a height of 0, and up, and then over. There we go. Yeah, this one's not very accurate, is it? No, it is not. So to find the area of this one, it would be my width of 5 times my height of 0. Yeah? So that's going to be what? 0, right? Yeah, okay. And what about this side over here? It's a width of 5 times a height of, it's 25. Why do I know it's 25? If this is 5, just plug it in to figure out where it's going to be. Yeah, just plug it in to figure out the y value, right? So it's 25 times 5, so that is a total area of, if I got 5 quarters, how much I got? 125, right? So 5 times 25 is 125. Okay, so is that very accurate? No, that's not very accurate. So let's try it again then. Now this next one, we're trying with 5 subintervals. So to do my subinterval, I would start off with, how would I write that? B minus A. What's my B here? Try again.
E would be
10, right? Minus A, which is over N. In this case, my N is?
10.
There we go. And so my interval length is? 2. 2. All right, again, subintervals if I wanted the lower bound. So I'm going to break each one up into 2s. So let me see. 1, oh man, I'm not very good at counting this. 4, here's 2. Four. All right, again, we're doing a lower bound, right? Lower bound. So that means always from the left-hand side in this case. So the left-hand side of my first interval is 0. So the height is 0 there. And what is the height of my second one? What did I say to do if you don't know? It's 4. Where do we get 4? Yeah, plug it into the function and figure out the height. So we know it's at 2, right? So 2 squared is 4. So that area right there would be 4 times 2 is 8. Okay, good. All right, what about the next one? So the next one, what's the height of the next one?
36. 36?
Not 36.
Alright, get up that.
You're too far. Look. It goes in intervals of 2, doesn't it? So this is 2. This is 4. This is 6. This is 8. This is 10. Is that better? Okay, which one are we at now? We're at 4, aren't we?
Oh, we're at 4? Whoops.
We're at 4.
So that would be 16.
16. So the height would be 16, wouldn't it? So the height is 16 times 2. That one's 32. Okay. The height of the next one is 36. And 36 times 2.
Oh, 72.
72. So the area of that next one's 72. Okay, and okay, my last interval here. My last interval would be, what's the height? 64. 64 times 2?
128.
128. So I have 128 times 72. Plus 72 plus. Did you write down any of these as I was going?
160 plus like 16 would be like 76 plus like 52.
Is that better? Okay, I wrote it down now this time. 240. This and this gives me 200. This and this gives me 40. All right, now, is this going to be an overestimate or an underestimate?
Under.
It's all under, isn't it? Okay, so what can you tell me in between the two things that I just did? What happened when I divided it up into more intervals?
The area got bigger.
Area got bigger. But it goes back to your first statement that you made for about the last one. More intervals will mean
More accurate.
more accurate. More intervals will be more accurate. So we're eventually going to try and take the intervals to infinity
Whoa.
With the sums.
and beyond. I've been waiting all semester for that one. Okay, anyway. Actually, I'm going to stop right there. I'm going to let you guys work on some of the homework. I'm going to pick up this tomorrow. Andy, we're finding the sum as n goes to infinity. So we keep saying that the more intervals, the more accurate, right? What if I have infinity intervals?
Then that's gonna
The
be.
most accurate thing.
No, it's never gonna be most accurate though, because it's gonna be as close accurate as it can get. It's the limit.
Okay, so as we take the limit to some number, right, it goes to something.
It goes to something, but it never touches it.
Okay, but what we're going to do, we're doing a summation of infinite number of parts. And so once we actually do that, we have so close to it that it is accurate. Okay. Anyway, we'll talk about it more tomorrow. Okay, don't forget, like, share, subscribe, hit that notification button, and don't forget, follow the link in the store down below right about here. Yeah, buy some merchandise. We got hoodies on sale right now.